Alright, in this video we're going to look at solving systems by graphing. And so we're talking about linear systems. So it means we're going to have two equations that are both linear equations. So for this problem, we're going to have y equals 1/3 x plus 2 and y equals negative 2x plus 9. So that is our system. Now what we're trying to find is find on a graph where these two lines intersect. And so we're going to switch to graph paper in just a second. We're going to graph these like we would if they were in slope-intercept form, since they are. So remember, slope-intercept form, we'll start with our y-intercept, and from there we'll count our graph. Alright, so if we'll go on and look at our graph, I'm going to draw in an x and a y axis, and then go ahead and look at my first equation. So it is not going to work. I'm going to erase this real quick. So remember, with our slope-intercept form, we're going to need to go to the y-intercept first. And so if I look at that second equation, my y-intercept is 9. And so I realized that my graph was not going to be big enough. Alright, and we're going to pretend that I can draw straight lines. So my first equation is 1/3 x plus 2. So I'm going to start at 2 on my y-axis. My slope is 1/3, so I'm going to go up 1 and right 3, up 1, right 3, down 1, left 3 to go some to the left. And so if I draw a line through that, that is my first line. Okay. Alright, so now let's do the second one. So the second one is negative 2x plus 9. So I'm going to go to 9 on my y-axis. My slope is negative 2, or negative 2 over 1. So from this point, we'll go down 2 and right 1, down 2 and right 1, down 2 and right 1. And you can see I have found the point where these two lines intersect. And so I need the ordered pair for where those two intersect. And I can see that that point is at 3, 3. So that would be the solution for this system, 3, 3, because that's where the two lines intersect. Okay, so we're going to try this again. Alright, so if we look at these two equations, you can see the first one is already written in the slope-intercept form. The second one is not. So before I want to graph these, I need to take that second equation and change it to slope-intercept form. So that'll make it a little bit easier to graph. So we're going to divide all of this by 3. And that's going to make this y equals 2x minus 2. So if I graph the first one is 2x plus 3. So we'll go to 3 on our y-axis. My slope is 2, or 2 over 1. So I'm going to count up 2 and right 1, or down 2 and left 1 to get that line. So that is my first equation. Alright, now for the second equation, it is y equals 2x minus 2. So I'm going to start at a negative 2 on this one. My slope is also 2 over 1. So up to right 1, up to right 1, up to right 1. And what you should be noticing is these two lines are not getting closer or further away from each other. They are staying the same distance apart. And if you look at the equations, you'll notice that they have the same slope. So the slope is that number in front of the x. So we've got a 2x and a 2x. And when the slope is the same, that means that we have lines that are parallel. So when you have parallel lines, you're not going to have any place where they intersect. And your solution is the intersection point. So since these lines don't intersect, we would say there is no solution. Okay, so that's going to happen anytime you have the same slope on both of them. Alright, so here I have two equations. The second one is not in slope-intercept form, so I'm going to go ahead and change that. So I'm going to subtract the x from both sides. That'll give me negative y equals negative x minus 2. I'm going to divide by negative 1. That's going to make that a positive y equals positive x plus 2. So I want you to look at our two equations. We have y equals x plus 2 and y equals x plus 2. So you may already be noticing those are the same line. So if I graph that first one, y equals x plus 2, we'd start at 2 on the y-axis. Remember, when there's no number written in front of the x, that's an understood 1. or 1 over 1 if you want to write it that way for rise over run. So up 1 and right 1. This line represents y equals x plus 2. Now if you look at the other line, it also says y equals x plus 2. So if I do the exact same thing again, you can see I'm going to end up with all of the exact same points. So how many points do these two lines have in common? Well, they're the exact same line, so they have every single point in common. So what we say on a problem like this is we say that there are infinitely many solutions. So when you are solving a linear system by graphing, there are three things that could happen. You can have one place where the two graphs intersect, and that is the solution, that ordered pair. You can have two lines that are parallel with the same slope. They will have no solution. Or you can have two lines that are actually the exact same line, where it will be one line on top of the other, and so there are infinitely many solutions.